Yes, good afternoon everyone. So last day I have discussed on the electrode potential. Electrode potential. Okay, the electrode potential, that is potential generated due to the electrical double layer, or you can say that it is the potential due to the cationic part and the neutral part in the solid phase in the solution. Okay. Now, today I will discuss on the questions from this chapter. Okay. Have you any query? Redox reaction. Redox. Okay. So, calculate, the chapter is redox reaction. I hope it is the unit 6. Yes, no, unit 8. Unit 8 redox. Okay. So, today I will discuss some questions. Now, calculate the standard reduction potential of CD2 plus CD, that is cadmium electrode for the cell. Calculate the standard reduction potential for CD2 plus CD for the cell, that is Zn Zn2 plus CD2 plus CD, Zn Zn2 plus CD2 plus front slash CD. Okay. Now, calculate the standard reduction potential for the cell. The E0 value is given, E0 cell equal to 0.36 volt and E0 of E0 cell equal to 0.36 volt, and E0 of Zn2 plus Zn equal to minus 0.76, Zn2 plus Zn equal to minus 0.76 volt. Now, Zn2 plus Zn, it is the reduction, Zn2 plus Zn, it is the reduction. So, here the reduction potential is in minimum, so it will act as an anode. So, the cell construction of cell, that is Zn2 plus Zn double slash CD, Zn2 plus Zn CD2 plus, because first one is of oxidation, Zn2 plus and CD2 plus CD, because first one is oxidation, second one is reduction couple. Now, E0 of cathode minus E0 of anode. The cell is given Zn Zn2 plus CD2 plus CD. Now, E0 of cell, that is of E0 of right, this minus E0 of left, E0 of right, that is CD2 plus CD. The value of CD2 plus CD is not known, so it is E0 of R minus E0 of left, that is left Zn Zn2 plus, the value is given of Zn2 plus Zn. Okay, so we have to revert the value, that is equal to 0.76 volt, that is minus of minus 76. Now, the E0 cell is given, that is 0.36. So, E0 of R equal to 0.36 minus 0.76. So, it is equal to minus 0.40 volt. Have you understood? Have you understood? Okay. So, this part is clear to you. Now, I am going to few more questions from this chapter. Assign the oxidation number to the elements in the following series, that is K2MnO4. K2MnO4, the oxidation state of manganese. Calculate. How to calculate? Calculate the oxidation number of manganese in K2MnO4. Can you do it? Respond in the chat box so that no one can answer. Okay. So, the easiest method is that assuming it as X, the oxidation state of manganese assuming at X, potassium having +1 into 2 plus X plus -2 into 4, they are having no overall charge, it is 0. So, it is equal to 0. So, 2 plus X minus 8 equal to 0. So, X equal to plus -6 plus 6. So, the oxidation state of manganese is +6. Clear? Clear? NaH2PO4, NaH2PO4, the oxidation state of phosphorus. Oxidation state of phosphorus. What would be the oxidation state of phosphorus here? Now, you can do it. Sodium +1, hydrogen +1 into 2, that is 2, plus X minus -2 into 4, that is -8, overall 0. So, it is equal to X equal to +5. So, the oxidation state of phosphorus is +5 here. Clear? Sulfur in H2S2O7. Sulfur in H2S2O7. H2S2O7 sulfur. How to calculate it? Two into +1 for hydrogen plus 2x minus 2 into 7, it is equal to 0. Now, x 2x minus 14 plus 2, that is of plus 12, minus 12 equal to 0. So, x equal to plus 6. So, here the oxidation state of sulfur is plus 6. Oxidation number of some compounds related with organic compound, that is the oxidation number of iodine in Ki3, oxidation number of iodine in Ki3. Already we have come to know that in some cases the oxidation state may be of fraction. So, here potassium having +1 oxidation state, it is here valency. So, +1, that is 1 plus 3x equal to 0. So, x equal to minus 1/3. So, here an exception of this rule. What is the oxidation state is that it is depends on the bonding pattern, that is ligation, the bonding in KO2. Here a coordinate covalent bond and a covalent bond is there, and for this reason this type of structures is there. One example, that is what is the oxidation state of carbon in ethanol. Okay. That is CH3 CH2OH C2H6O. Now the oxidation state of carbon, that is just assuming it as X. Plus 6 minus 2 equal to 0. So 2x plus 4 equal to 0, x equal to minus 2, x equal to minus 2. Yes, so the oxidation state of here is equal to x of minus 2. It is the general oxidation state of carbon. Okay. Now coming to the next question, that identify the reaction as it is a redox reaction. 6CO2 plus 6H2O, 6CO2 plus 6H2O forming C6H12O6 plus 6O2. Identify it as a redox reaction. Now you can see that it is very typical one. Now in the reaction there is a C6, that is carbon dioxide to carbon. Here carbon is a non-metal, carbon is non-metal here, non-metal, that means the halide. Here it will from CO2 to CO2 to O2, air liberation of carbon, that is a non-metallic type. So it is one. The oxygen just resembles with the oxygen, that is liberation of oxygen is takes place. So here it is reduction. And last one here H2O. There are some incomplete reaction, C6 CO2 plus H2O plus C6H12O6 plus O2. So in there is a more component is there, 6O2, C6H12O6 and 6H2O is also there. So this part is reduction and this part, and the next part is oxidation. Another one example, that is NH3 plus 5O2, NH3 plus 5O2 forming NO2, NO and H2O forming NO plus H2O. Now this one is easy. First one was the oxidation reduction reaction, second one NH3 to NO. Now hydrogen is eliminated from NH3 to form NO and oxygen has taken place. Both these guys, it is the oxidation, and in the second one hydrogen has been added with oxygen, this is the reduction. So this part is the reduction and this part is the oxidation. So it is a redox reaction. Next one very important is there, balance the chemical equation by two method. One is oxidation number method and another one is ion electron method or half reaction method. Okay. Now there are some important questions is there. Predict the product of electrolysis of each of the following. Predict the product of electrolysis. Now what is electrolysis? You have the concept from class 10. Okay. Now in electrolysis there is the mobility of the ion is there and it depends on the discharge of the cations and anion. Just when we make electrolysis of aqueous NaCl solution, what happens there? In aqueous NaCl solution there is H2O dissociates as H plus OH minus, NaCl dissociates as Na plus Cl minus. So there are 4 cations and anions. Now according to the law of electrolysis, cation moves to cathode and anion moves towards the anode. Now the cation, here the cations is H plus and Na plus and anion is Cl minus and OH minus. Now what happens? There is a competition of H plus and Na plus and OH minus and Cl minus. Now there is a term, that is discharge potential is there. The term is discharge potential. What is the discharge potential? Whose discharge potential will be less? It is according to the series, that is redox series, that is the electrode potential series. Whose discharge potential will be less, it will discharge in the, that it will deposited on the metal or it will be free. Okay. So it will depend on the discharge potential. Now H plus and Na plus, the H plus having lower discharge potential or the mobility of H plus is higher than that of the sodium. So hydrogen will, H plus will form hydrogen and liberate. So in solution there is Na plus, and in between Cl minus and OH minus, the mobility of Cl minus, that is the discharge potential of Cl minus is less. So Cl will liberate, Cl as Cl minus as Cl2, and in the solution it is the OH minus. So the solution overall is basic in nature. It is also a preparation of sodium hydroxide, that is aqueous solution, that is electrolysis of aqueous solution of brine. Brine, that is NaCl, produces NaOH. You have studied it on class 10. Now on this concept, an aqueous solution of silver nitrate using silver electrodes. Electrolysis of aqueous solution of silver nitrate using silver electrode. Okay. So the compartment is that here silver nitrate solution and here silver rod, AgNO3. Okay. Now electrolysis produces the AgNO3 produces Ag plus and NO3 minus, and H plus, H2O produces H plus and OH minus. Now again there is a competition in between these ions, that is Ag plus and H plus and NO3 minus and OH minus. So Ag plus having less discharge potential, Ag plus having less discharge potential, as it is cation goes to cathode, so it will deposit on cathode. and in between NO3 and OH minus the mobility, that is discharge potential of NO3 minus will be less. So, it will be evolve from the system, and the system there is the OH minus and H plus. Okay. So, Ag will get deposit on the cathode, and another one it will be the liberation of NO2 gas from the NO3. So, in this way we have to solve this, and there is the very important part on the discharge potential. There are some factors on which the discharge potential depends. One is the charge of the cation or anion. Okay. Now, next one is the size and the number, that is the concentration of the cations and anion. If the equation produces 2 Cl minus with respect to any one monoatomic, then the concentration of Cl minus will be higher. So, in this way there are some factors on which the discharge potential depends. Next one, an aqueous solution of silver nitrate using a dilute solution of H2SO4 using platinum electrode. A dilute solution of H2SO4, dilute H2SO4. So, dilute H2SO4, that is H2O forming H plus, OH minus, H2SO4 forming 2H plus, that is again H plus and SO4 minus. So, here only one cation, that is H plus will goes to the cathode, and OH minus and sulphate. Again the competition is there in between OH minus and SO4 minus. Now, SO4 having large size, and more discharge potential, the OH minus will discharge on the anion, that is in the anode. So, in this way we can solve out the problems regarding to the electrolysis of the aqueous solution of silver nitrate or dilute H2SO4, etc. Next, arrange the following metal in order in which they displace each other from their salt. The salt, that is the aluminium, copper, iron, manganese, magnesium and zinc. Iron, magnesium and zinc. We have to answer it by using the electrode potential or the position of the metal on the electrochemical series. Now, the more reactive metal will substitute the other from the salt. Okay. Now, the arrangement of this will be, which one is most reactive out of this? Magnesium, then zinc, then aluminium, then iron and then copper. Okay. So, using the electrochemical series we can predict which one can displace the others. Okay. That is all for today. Okay. On the next class we will discuss some more problem regarding to this chapter. Okay. So, bye everyone. Thank you for staying with us. Recording was on. Recording.